That seems really loud. There we go. Chapter 2. I'll type this one because my handwriting is so atrocious. Elements and the, can you figure out the blank that goes before the word table? Periodic table. This is the alphabet of the universe. This, if you asked me to list the top 5 scientific discoveries of all time that led to many, many more discoveries, the idea of the periodic table would be in the top 5. I would also put calculus, invented by Sir Isaac Newton. It's not a coincidence that the Industrial Revolution began shortly after Isaac Newton invented calculus, because now a whole bunch of engineering problems could be calculated and solved instead of built, guess and check, and hope you were right, and maybe that wasn't the best way to build it. Here's where it gets really good. This is a quote. You don't need to know this quote, but I'm a nerd. This is #nerd trivia. Richard Feynman, the physicist who won a Nobel Prize, and I'll go on a Richard Feynman rant another day because he's one of my nerd heroes. If, he said this, in some cataclysm, all scientific knowledge were to be destroyed, and only one sentence could be passed on to the next generation of creatures, which statement would contain the most information in the fewest words? I believe that it is the atomic hypothesis, or atomic fact, or whatever you wish to call it. That, here it is, you ready? And you already know some of this. All things are made up of atoms, little particles that move around in perpetual motion. There's your kinetic molecular theory. Attracting each other when they are a little distance apart, but repelling upon being squeezed into one another. In that one sentence, you will see an enormous amount of information about the world, about the universe, if just a little imagination and thinking are applied. And I'm going to try and convince you of that over the next few months. You're going to get a worksheet in a little bit to familiarize yourself with the pink periodic table. That's going to be your homework for Monday or for Wednesday. Probably for Wednesday, since you have a test Monday. I don't think I'm going to get all the way through this lesson today. We'll finish it in the second half of Monday after all of you finished your test. Okay? But we have to show you the periodic table of the elements song. In terms of a single piece of paper, your periodic table contains more information per line than almost anything else out there. So first of all, let's meet the elements. There are 92 elements that occur naturally in the universe, although some are very rare. And there are also around 25. The symbol for around is that little squiggly thing. I've told you at the beginning of the year I tend to abbreviate. Yes, Brianna? So I'm going to teach you some shorthand. That only exist in the lab. Most of them only exists for tenths of a second or hundredths of a second or even trillionths of a second. They have what we call a very short half-life. They only exist for a short time, and then they decay radioactively into something else. Everything else in the universe is made up of a combination of those 92. This is why Richard Feynman suggested that that one sentence had so much information. With a bit of cleverness, you can deduce how everything in the universe is made. All elements are represented by a 1 or a 2 letter symbol. Mr. Dueck? Yes, David. I think you're fibbing. I'm looking at element number 118. Look at your periodic table. It's in numerical order. The first one is 1. Near the bottom somewhere will be element number 118. That's represented by, is it 3 letters? Yeah. What are the 3 letters? U, U, O. That's a placeholder. That's Latin for 118. U1, U1, and then octo, O, 118. There's a procedure where elements are named after people, and I believe your periodic table is already out of date. Last year, they named a few of those, the ones that have the UUO, UUT, they've named some of those. But for the most part, once an element has its official name, 1 letter or 2 letters. No 3s. Some of these make sense. What's the symbol for carbon? Carbon is element number 8. Go find it on your periodic table. Carbon is C. Some of these don't make sense. What's the symbol for gold? A. U. A gold atom walked into a bar and then walked off without paying. The bartender said, "Hey, you!" See? There's your joke. They only get worse. AU makes sense if you speak Latin, because the word for gold in Latin does start with AU, but also not every element was discovered by people that spoke English. Sometimes the word comes from their language. Think about the headphones that you listen to. What are they made of? This is not in your notes. This is just to get you thinking. There's copper that carries the signal from the music player to the headphones, because copper is a good conductor. There is gold inside your headphones to help transmit the signal. There are magnets which convert the signal to sound. Typically, those are made of iron and boron and neodymium. All of these elements are all around you all the time. We could list the elements that are in the clothing that you wear. We could list the elements that are in the skin that you possess. You yourselves are mostly carbon, and then some hydrogen and some oxygen. But you're mostly carbon. You're carbon-based creatures, carbon-based life forms. There are 3 main groups of elements. There are the metals. There are the non-metals. The metals are on the left-hand side of the periodic table. There's lots of them. The non-metals are on the right-hand side. Look at your periodic table. See, there is a thick black staircase line about 2/3 of the way over? That's the dividing point. But elements right along that thick black staircase line behave a little bit like metals, and they behave a little bit like non-metals, depending on the situation. We call those metalloids. The reason all of your computer chips are made of silicon. Silicon is a metalloid. We can get it to behave like a metal and conduct when we want it to, but we can also get it to behave like a non-metal and not conduct when we want it to, and just by doing that, we're able to build molecular on-off switches. It'll start electricity and stop electricity just by tweaking a few things. By building what's called a transistor. Do a Google search or a YouTube search for how does a silicon transistor work, and you can dive into that. It involves some quantum physics. But that's why everything got miniature all of a sudden. Metals. Most elements. Usually hard or solid, except there's one at room temperature. Sorry, I should say usually hard at room temperature. There's one metal that's liquid at room temperature. Does anybody know what it is? There's also a planet named after it. Mercury. This is why when your grandparents were growing up, mercury was used inside thermometers, because mercury stayed liquid at room temperature, and as it heated up, it would expand slightly, and that's what would make it go up the tube, and you just put a scale along that tube calibrated to the mercury expansion. Lo and behold, thermometers. The big problem with mercury is it's very poisonous and toxic. And not only is it poisonous and toxic, at this point we don't have the technology to cure mercury poisoning. In fact, there is a possibility that may be impossible to cure mercury poisoning. It binds with the brain receptors in your brain and replaces the healthy chemicals that are supposed to bind with the neurons with itself. And it's a stronger bond than the healthy ones, and that's why it may be impossible to fix that. So don't play with mercury. When I was in high school, they had gotten careful with mercury, but people who are even slightly older than me, Mr. Perugia is only about 5 years older than me, he will tell you when he was in high school, you would bring mercury out, you would put it in your hand and let it roll around. It has a really, really high surface tension, and so if you put a drop of mercury liquid in your hand, it almost forms a ball instead of making a puddle, because it's got such a high surface tension. It's kind of weird. They are shiny, and they conduct electricity. They are malleable. What does malleable mean? Who remembers? That's a vocabulary word that might very well show up on your test on Monday. Quinn. I think the official definition is it can be pounded flat into sheets. Yep. And they possess ductility. What was that one, Sarah?
Can be made into wire.
Yeah, and that one I remember. Copper wires. There's a reason why we use copper. It's very conductive. By the way, it's not the most conductive. The best conductor is gold. Why don't we use gold in our wiring? Yes. Now, the people who do, by the way, the reason NASA space probes cost so much is almost all of their wiring is gold, because you want the best possible conductor out there so that nothing goes wrong. Second best conductor is silver, also too expensive. Third best conductor is copper. That's why we use that. And there's a fair bit of copper out there. Some examples of metals. Look at your periodic table. Stay on the left-ish, the left half or so. Tell me some metals. Give me one. Sarah. Rutherfordium. What's its symbol? We will abbreviate. You can write out all these elements if you wish, but this is some of the best shorthand out there. What element number is it?
104.
Element 104. Find it on your periodic table, all of you. It's element 104. You got to kind of scroll along. It is named after Ernst Rutherford, the Rutherford experiment. He got an element named after him. Okay, there's a rule that was only broken once. The rule is you can only name elements after scientists who have died. There is one exception to that. Seaborgium was named after Glenn Seaborg, who had discovered, and his lab had discovered many, many elements back in the 50s and 60s at Berkeley. And his lab had discovered the element, and shortly after that, the Russians had discovered the element, and it was the height of the Cold War, and so his lab decided to name the element Seaborgium because they knew if they did that, the Russians, who respected Seaborg so much, wouldn't give the element their own name. It was a political thing, and so there's a terrific photo of a 90-year-old Glenn Seaborg standing next to a giant periodic table, smiling sheepishly, pointing at the element named after him. It's the only one of its kind because you're not allowed to name them after living people anymore. There's an International Atomic Committee, and that's one of the rules that they set up. There had to be some kind of systematic, we got to have some kind of naming procedure, otherwise different countries' periodic tables will look different from each other, and that leads to chaos in manufacturing. We don't want that. So there's actually an international committee that decides these things. Give me another metal.
15.
Sorry?
15.
Symbol?
TI.
And if it's two letters, the second letter you'll notice is always lowercase. First letter is always capital. Give me a one-letter metal. What's the symbol for potassium? Okay. What's the symbol for sodium? Right above it.
Nah.
Mr. Dewitt, can you tell me a joke about sodium? Nah. Can you tell me a joke about potassium? Okay.
Why?
That's on. I don't know if there's an element that is only a Y. There's several elements that begin with the letter Y. There's.
There is. There is.
Oh yeah, yttrium, right?
Yeah. I don't
Yeah.
Lithium.
Element number 39. 39. I'm reading from back there. Non-metals.
Sodium.
First of all, in our notes,
Brownie.
only a few elements. Usually at room temperature, these are gases or brittle solids. In other words, they're nowhere near as strong as metals, which probably you've clued in just because you've grown up. Metals are strongish. You have that idea. Okay? Except bromine. It's an exception. It's a bit weird. They're not shiny. They're not malleable. They're not ductile. They don't conduct electricity, hence non-metals, because they don't do all the things metals do. Some examples. Symbol K or KR? And you thought that was only Superman? Nope. Arsenic. Symbol AS? Thorine, TH, or just TR, or you say chlorine or thorine? Chlorine, that's Cl. That one I know. Okay. And then we'll talk about those metalloids, but I'll be honest, in Science 9, for the most part, we're going to ignore the metalloids because, Brianna, they don't behave the way the other elements are. Oh, and I should point out, everything that I'm teaching you this year that I'm going to say is a rule is technically wrong, because when you build large hadron colliders and start smashing these things together near the speed of light, all the rules can be broken. I should point that out, Gabe. But for the most part, when I say something is a rule, I mean at normal speeds, in a regular lab, without $2 billion of equipment, it behaves this way always. Metalloids. We'll have a very vague some elements, and they have some properties of metals and some properties of nonmetals. Some examples: silicon. Yes? Is that they're labeled? Are they labeled, or? And if you're not sure, there is a periodic table in your textbook that's in color, and it is on page. I used to have this memorized, but I've forgotten. If you happen to have a textbook handy and you want to see this periodic table in color, you can open up to page 54. Under the B, 5. Under the I, 4. And then you can see the metalloids outlined in a nice greeny color. Boron is, yep. Boron is B, yes? Okay.
Are we going to learn about the different groups?
Yep. Sorry, some. And we don't call them groups, we call them families. Yep. Here it is. I knew I had a color picture somewhere. Are the metalloids, do they stand out at all on your, because I was photocopying a color diagram. Okay, there's the staircase there. If you want to, sometime with a pen or a pencil or a different color, you could trace out that purple area, or from page 54 in your textbook, because you're allowed to bring this in. You must bring this into your tests, the pink periodic table, and I'll let you add that to the sheet because I just couldn't get it to photocopy nicely. But I wanted you to have one of your own. Okay. One of the elements is kind of strange because it appears on both sides. Have you noticed? Hydrogen. Hydrogen can behave in many situations like a metal. It can behave in many situations like a non-metal. It's the simplest and most common element in the universe. Why? We'll get there. Elements close to each other generally have similar properties. Those that are further away generally have different properties. Elements, and this is not on your notes yet, it'll show up later, but just to answer your question, because you asked about families, elements that are in the same vertical column will often combine in the same way with other elements as the ones right above them or right below them. That's why they're in those families. If you want to be more specific, elements in vertical columns have identical outer electron shells. Names and symbols. Where do these names come from? Well, some are from Greek and Latin. Some of the more recently discovered ones are named after famous scientists: Rutherfordium, Einsteinium. I think 114 or 118 got named Feynmanium after Richard Feynman. One of them was named after a town in Japan where it was discovered. They decided that they named about 4 of them just last year. They've been talking about it for about 5 years, and it had votes and symposiums and meetings and stuff like that.
Which countries found the most
Which country has found the most elements? There's one location where many elements are discovered, and it's a Swedish city, I think, called... Yeah, because a lot of the ones that begin with the letter Y, there was a mine, and back in the early 1800s, this particular mine just happened to have a whole bunch of new elements that people hadn't spotted. So there's yttrium, there's ytterbium, there's scandium, because for Scandinavia, Sweden, there's about 5 or 6 if you go through that you'll kind of see, oh, I'll bet you they were discovered there. If you're really a nerd and you want to get into this, I can give you a great book to read. It's called The Disappearing Spoon. It's a history of the periodic table. All it goes into is the really, really bizarre stories of the discoveries. You'll find that wars have been fought. You'll find that during World War II, the Germans had a secret undercover mining operation in the U.S. because molybdenum, if you added that to your artillery cannons, you could make them bigger and longer. The problem with artillery cannons, imagine a big long cannon. As it heats up, when you heat up metal, what happens to it? It tends to, looking for a word that begins with the letter M and rhymes with elt. Okay? So they would droop. Turns out if you add molybdenum to that, you can make much larger cannons and therefore bigger guns and anyways, all sorts of stuff. Hi there!
Hi, I'm just here to help cover your class while you set up sound, apparently.
Okay.
And I am so qualified to teach you guys. It's amazing. I can't wait. But I can come back when you're ready. But
10 minutes?
10 minutes.
Would be perfect.
Okay, I'll be back.
Thank you. It says here, see page 44 for a list and then complete the worksheet. I'm going to be giving you both of those in a few minutes and I'll walk you through it. We got to talk about mercury. It's very cool. Mercury is the only metal that is liquid at room temperature. Now, this doesn't make it that special. You can make any metal liquid, just heat it up. It just happens to be the only one that has a melting point at room temperature, below room temperature. It's very, 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 very toxic. Liquid mercury itself is not that toxic, but the gas that it gives off as it evaporates is. And so if you breathe that in, you get mercury poisoning. There's an expression called mad as a hatter. Back when hats were made out of felt, if you were a hat maker, that felt often had lots of mercury in it. And so the expression mad as a hatter probably came from the fact that they were inhaling a lot of mercury fumes. And if you do that long enough, you will go insane. It'll make your brain stop working properly. A little depressing nerd trivia for you there. We have a problem now with mercury because we dumped too much of it into the oceans in the 50s and 60s and 70s. The amount of mercury that fish have right now is far higher than it was, say, 60 years ago. And if you eat seafood, you are ingesting some mercury, no matter how hard you try. This is why pregnant women are advised to avoid seafood while they're pregnant. We don't have any way to get rid of it. So this can lead to problems with the central nervous system, coordination, as well as developmental problems in fetuses or young children. And this is non-reversible with our current level of technology and probably always will be unless, Paige, we come up with like magic Star Trek beam me up technology. But right now, we don't have that. I think I'm going to show you a scary picture. Oh, not yet. Yeah, here's the scary picture. This is from the 1950s before this is dangerous. Okay? That's a tank of liquid mercury. It's so dense that you float on it, but you float on it on the very, 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 very top because it's much denser than water. The only concern I have there, he is inhaling mercury fumes right there. Probably at the time they didn't realize that it was that dangerous. This is from the 50s or 60s, but he is floating. It's just way denser than water. So very dense. No, but you can sit on it. For what it's worth, bricks would float on it. It's very useful, though. Many dental fillings have a compound of mercury, and when it combines with something and it's stable, then we're good. It is used all the time to make sparkless switches Let me see if I can show you how it works. So, imagine this container, instead of Skittles, had mercury. Okay? A sparkless switch is one that you can switch on or off by tilting it. Because the mercury conducts electricity, you have your wire here and your wire here, but they're not connected. If you want to turn the switch on, the mercury flows to the bottom and the electricity can flow through the liquid mercury. Well, that's not very good. That came back, thankfully. My projector is not going to be too happy. Speaking of sparkless switches, and then when you want to turn the switch off, you tilt it this way and now no electricity can flow. So, very, very clever system.
That was perfect timing. I thought it would actually work. So
Okay.
scared.
The next blank, where it says there's a blank, and then to purify gold, I got to wait for my projector to warm up again. Mining.
Kind of funny that happened just as you turned.
I know that.
Mining to purify gold, etc. The problem is, this is why mines are such bad polluters, especially the older mines. There's mercury tailings all over the place sitting in the environment. It leaches into the groundwater, then it leaches into the ocean, and now all our fish have mercury poisoning. And it used to be, the next blank, it used to be used in thermometers. Thermometers. Now thermometers have alcohol, but if you have an old thermometer and it breaks, it falls to the floor and it breaks, and if you notice the liquid inside of it balls up on the ground instead of staying flat, get your parents to carefully clean it up. Don't clean it up yourself. And to be honest, like if it happens here, we have a hazmat suit we'll bring out just to be paranoid if there's a lot of mercury. Okay? Let's see if the projector will come back now. I have a video I'm going to try and show you. It's of a balloon full of mercury being popped. And you lose. Take a look at the sheet that I just gave you. It's called Exploring the Periodic Table. Looks like this. And let me explain to you how bad the puns are. This is what we're getting at. So the first one says, we brought everything but the kitchen zinc, which is element number what? Find it on your pink periodic table. Pardon me? We haven't got there yet. We'll pick up next class. We haven't finished the lesson. I think I said I wasn't going to finish the lesson. Element zinc, I think is number 13. No, is it 13? 30. And you can write the word zinc, or you can write ZI, which I tend to...
ZN.
Oh, ZN, I'm sorry. ZN. Okay. I suddenly just lost everything here. Let's see if I can bring it back now, Mr. Dirk. There we go. Z... Geez, that didn't work. Let's try that again. ZN. Dial 911 to call a copper. Okay. They're all going to be that bad. We will go over the answers, and I'll give a candy if you think you get it right. The one you can do is on the back page. Oh, and then there's a story. I'll give you a hint. It says, translate this poem. PB, what's that one? We'll talk about this next class. Oh, I am so sad. I wish I had some AU. Which one is that from your period? Gold or AG. Which one is that? Silver. You can fill in those. And then there's a bit of a crossword on the back where I've given you the element. You can fill in the name. I did have to fill in one of the elements. This is a crossword from Britain. And in Britain, instead of spelling it with an F, they spell it with a PH. That's why I put a PH in there for you. That is not due Monday. Monday is your test. That'll be due Wednesday. And this is not something I'm going to test you on. I'm totally doing this to get you a little bit familiar, Brianna, with where stuff is. Okay? I had promised you a video showing a mercury popped balloon. I'm going to show that at the beginning of the next lesson.
I could have done that. I could have clicked the video.
I know.